Hey there, ladies and gentlemen. Welcome to lesson 8-9. It's the final lesson of chapter 8, which also means it's the final lesson of trimester 2. So that's kind of an awesome thing all tied together into one. This lesson's all about trying to find perfect square trinomials. And you'll see at this very beginning of the screen here, we are looking for another pattern. But this lesson also has us trying to tie together all of the things that we've learned through chapter 8. So a perfect square trinomial is when we have the factored out version of our answers where they've been in this form. We have an a plus b times an a plus b, which turns into this type of a form. So what we're doing is we're trying to take and turn it back into that form. So the answers in the a squared plus 2ab plus b squared, we want to turn it back into an a plus b plus times a plus b. And the same idea with the negative ones here. So if they start out as after they've been FOILed, we get an answer that looks like this. And our job is to then remember that they look like that before we FOIL them. So that's what we're looking for. So big ideas here. There's a couple different methods that we need to look at. Step 1 for all of our problems is to take out a GCF. Step 2 is to check for a difference of square patterns, a perfect square trinomial patterns. And if they don't have those, then we're going to look at what we did with our other lessons in 8.6 and in 8.7. So we're looking for the 8.6 method, which looks like this, where we're multiplying to see what multiplies to make a C but adds to make a B. Or we're looking at the 8.7 method, which is to multiply A times C and see what adds together to make a B. Or our final option is, if there's 4 or more terms, is to factor by grouping. So we're looking for those things to help us make sense of all of these items. Now, because we had to talk a bunch about all that stuff, we're going to have to go kind of quick here with examples. So example 1 and example 2, are they perfect square trinomials or not? So to be a perfect square trinomial, we would take the square root of these numbers and the square root of this number. And then when we multiply these together and then times 2, we would get the middle number. If they do work that way, then it's a perfect square trinomial. So this one is not a perfect square trinomial because 5 times 3 is 15x, but times 2 makes it a positive 30. The only way, oopsies. The only way this works out for us is if all of our numbers are going to be able to work. And I lied to you, this is going to be a perfect square trinomial. This one works because we could have a negative 5 and a negative and negative. That works for us. So this would be another beautiful number of a 5x minus 3 squared would be our answer. So this is a big fat yes. So this one works for us. On example 2, same idea. Square root of the first term, square root of the last term, a 7y and a 6. Those make a 42y. And then times 2 makes 84, not 42. So that's why this one is a big fat no for us. All right, similar ideas. On example number 3, we have a 6x to the second minus 96. Because we're not asking for anything specific here, we just need to factor. So you should always look for a GCF. Right now I see that I can divide both of these by a 6 to be left over with an x squared, and 96 divided by 6 I think is 16. Yep. And minus 16. And hopefully you see then that this is a difference of squares. So that breaks us down into an x plus 4 and an x minus 4, like we taught you from the difference of squares lesson. The 6 just comes straight down, and then that is our official answer. On example number 4, we're looking for you to choose a method. There is not a number that we can take out of all 3 terms, so there's no GCF. It is not a perfect square trinomial because 15, you can't take a square root of 15 and have a nice whole number. So then we're going to apply our methods back from 8.7. So we do a times c and get whatever that is. 16 times a negative 15 makes a negative 240. And then what adds to make an 8. So we're looking for what numbers multiply to make a negative 240 and add to make an 8. So I guess my normal things here, we know that because this is negative, one's going to be positive and one's going to be negative. So let's go with 12. I think 12. 240 divided by 12. 240 divided by 12 is 20. So a 20 and a 12, I think that works out nice for us. So a 20 and a 12 is what we needed. So we're going to trade out this 8 for a 20x and a 12x, or k. So we have a 16k to the second, and then we're going to put a plus 20k, and then minus 12k and minus 15. I'm going to group together in that same order because they kind of go nice together. Take out a common factor of a 4k, and I'll be left with a 4k plus 5. Take out a common factor here of a negative 3, and I'll be left with a 4k plus 5. So that gets us, these two make their own. We have a 4k minus 3 and a 4k plus 5 is our final answers. Now if it said equals to 0, we'd use the next step, but because it doesn't, we are done. And next one. Same ideas here. I'm going to let you guys actually solve this one on your own. We want to make this say equals to 0. So this will be one that we check in class. So I want you to try that one on your own. You're going to add 81 to both sides, and then we'll do that one in class. I'll do example 6 for us right now. All right, check this one out. We're going to actually go through the process of taking this perfect square trinomial and doing the work. So it's going to become a b squared minus 14b plus 49 equals 36. So I've quickly FOILed it. I'm going to then subtract 36 from both sides. And that gets me to have it equal to 0 like we wanted. And 49 minus 36 makes a 13. So I have a b squared minus 14b and then a plus 13. Now because we do not have a variable in front of the b, we're just looking at this as a what multiplies to make a 13 and what adds to make a negative 14. Now because 13's prime was just 1 and 13, and we know that this has to be negative, so these both have to be negative for this to still be positive. So I'm going to have myself as a b minus 1 and a b minus 13 as my two options for example 6 to be equal to 0. And then when I solve those, it's b minus 1 equals 0 and b minus 13 equals 0. So b is equal to 1 and b is equal to positive 13 because we just solved those really quickly. And that's how we do this, folks. That's how we're looking at this entire chapter so far, is being able to look at the problems, choose which method works best for you, and make it make sense. All right, if you need my help, make sure you shout out to me. This is the Bourbon Nation. I'm signing off, folks. Have a great day.